In this video, I am going to be discussing how you solve a limiting reagent problem and deal with what is left over from the compound that is in excess. So we have this chemical reaction in which 3 copper oxides, copper 2 oxide, reacts with 2 aluminum to yield 3 copper solid and aluminum oxide. How much of each compound is there if you start with 7.29 grams of copper oxide, copper 2 oxide, and 4.21 grams of aluminum? This is the signifier to you that you're dealing with a limiting reagent problem. When you get 2 different amounts of starting materials, reactants, that means limiting reagent. So the first thing we're going to do is start to figure out which one of these is the limiting reagent. So we're going to start with 7.29 grams of copper 2 oxide. We know from the molecular weight that 79.55 grams of copper oxide, copper 2 oxide, is in 1 mole of copper 2 oxide. That's the molecular weight. And we're going to just pick copper. In order to determine which one is the limiting reagent, it doesn't matter which one of the products we pick. We're just going to pick copper. So from the balanced chemical equation, 3 moles of copper 2 oxide yields 3 moles of copper. And so that's from the balanced chemical equation, the molar ratio from those coefficients. And 1 mole of copper weighs 63.55 grams. That's the atomic weight, or the molecular weight. There's really only one atom, but we can call it molecular weight. So that means that the grand total of copper that you can create from 7.29 grams of copper 2 oxide is 5.82 grams of copper. So that's our first step, to figure out how much copper we can make from the copper 2 oxide. And our second step, let's figure out how much we can make from 4.21 grams of aluminum. Same process occurs. We use the molecular weight of aluminum, 26.98 grams of aluminum in 1 mole. Balanced chemical equation tells us that 2 moles of aluminum will yield 3 moles of copper. Balanced chemical equation, those coefficients are the molar ratio. And then using the molecular weight of copper again, 1 mole weighs 63.55 grams. So the amount of copper that can be synthesized from 4.21 grams of aluminum is 14.9. That means that the copper 2 oxide is limiting. Whichever one produces the least amount, that tells you what the limiting reagent is. That means that my aluminum is in excess. We're going to have leftover aluminum at the end. So we know that the copper 2 oxide is limiting. That means that 0 grams of copper 2 oxide will remain. All of it will be used up. We then also know that the most amount of copper we can form is 5.82 grams. And now we've got to deal with the other 2. So we're going to figure out how much aluminum oxide is formed. So from that 7.29 grams of the copper 2 oxide, our limiting reagent, we're going to calculate out how much aluminum oxide is formed. So 79.55 grams of copper 2 oxide in 1 mole, the molecular weight. Balanced chemical equation coefficients tell us that 3 moles of copper 2 oxide forms 1 mole of aluminum oxide. And the molecular weight tells us that 1 mole of aluminum oxide weighs 101.96 grams. So the amount of aluminum oxide that's formed is 3.11 grams. Great. So now we have how much copper oxide is left over? 0, because it's all been used up. We know how much copper we have, 5.82 grams. We know how much aluminum oxide is formed, 3.11 grams. We've got to figure out how much aluminum is going to be in excess. We know we started with 4.21. We have to take the aluminum we started with, subtract the aluminum used to get the aluminum left. The aluminum used is gotten through stoichiometry. Again, we're going to start with that 7.29 grams of copper 2 oxide. That's our limiting reagent. We start everything with it. We know that there's 79.55 grams of copper 2 oxide. That's the molecular weight. 1 mole copper 2 oxide. Now the balanced chemical equation tells us that 3 moles of copper 2 oxide requires 2 moles of aluminum to react with it fully. So we're going to use that balanced chemical equation as a conversion factor to say that every 3 moles copper 2 oxide requires 2 moles of aluminum in order for it to react fully. 1 mole of aluminum has a molecular weight, or an atomic weight, 26.98 grams. So this tells us that 1.65 grams of aluminum is required for complete reaction. So how much is left over? We started with 4.21 grams of aluminum. We used up 1.65 grams of aluminum. So the leftover amount is 2.56 grams. So that's how much aluminum is left over. We determined how much aluminum oxide is formed. We determined that no copper 2 oxide will remain because it's the limiting reagent. And we determined how much copper is formed as well.